right, guys. I think they're ready now. So it must take a while to start. You online. All right. So we're gonna practice some surds, logs, and indices. Surds, logs, and indices. And we're gonna be working from past paper. Everybody can hear me? Can see the screen?
Yes, sir.
All right. So we're starting with this paper, which is actually the key paper from 2023. All right, that's what we're looking at on the screen. 2023 key paper. This is number one. Number one has a number of parts. And part D of that question is a logs question right here. All right. Now remember, the key thing is to know the laws of logs to the logs question. You can't do these questions unless you know the laws. All right. I went through the laws. All right, and even some additional information about logs that you must know in order to do the questions. All right. So they give us this log equation to solve. Right? Solve means you have to find the value of x that satisfy this equation. And remember, when you have a logs equation to solve, right, your aim is to bring this equation down to one of two forms. All right, either you want to bring it down to a form like this, that the log of one number equals the log of some other number, and they are at the same base. And if that is the case, you know that this would imply that the two values are the same, or the two quantities are the same. That's option one. Or you want to bring it down to log of a number to a base is equal to some power. And then this now would imply that this number is equal to this base raised to that power. And then you will solve this one. So given this equation, you want to bring it down either to this format or bring it down to this format. Now, based on the fact that I have a 3 on this side, it looks like it is better for me to bring it down to this format, right? This should be basically be my 3. So I'll take this equation and try to bring it down to that format. So I essentially then want to consolidate the log expression on this side. We are already at one base 3. All right. So just wanted to remind us of that. That is your general approach. All right, let's get into the question. So we're going to use the subtraction law, the second law, right over here, which is that the log of A minus the log of B is equal to the log of A over B. All right? That's what we're using, and this is a subtraction. So this side of the equation becomes, I take this equation and rewrite it. I put this over this. So I'm going to get log to base 3 of x squared minus 9 over x plus 3. So it's the log of this over this. All right? It's equal to 3. That's what we have. And it is starting to look like this. It means that this is your number n. This is your base b. This is your power p. All right? So it means that this thing is equal to 3 raised to that power 3. That's what it means. So we can write that. X squared minus 9 over x plus 3 is equal to 3 cubed. That this 3 raised to that power 3. All right? Now I can see this as factors, and I can see this as x minus 3 times x plus 3. It looks like it's going to cancel the x plus 3, so we can write that. So instead of writing this as x squared minus 9, I can instead write it as x minus 3 times x plus 3. And what that means that the x plus 3 would cancel from here and there. right? And this becomes 27, right? And so we end up getting x minus 3 equals 27, which would then mean that x is equal to 30. That would be the answer. And now when you're doing blocks questions, generally test to see if the answers would work. So for example, if I drop 30 here, this will work out to me find a log of a positive value, which is okay. If I drop 30 here, then this will work out to me find a log of 33, which also would work. Right? We can actually just test the answers with a calculator. Just test with a calculator. Where is it? It's right here. So we're saying the x is 30. So we're testing that with a calculator. It will be this log base 3 of 30 squared minus 9. And then we are subtracting the log base 3 again of 30 plus 3 is 33. So we get the answer of 3 right here. So we know that it is correct. All right, that is that. Now, what goes with that one? So this question could have been an hard maths paper as well. What go with that one so far?
Yes, sir.
All right, so this could have been an hard maths paper as well, right? This is hard maths level work as well. All right, so that is it. I'm trying to wonder about this cancellation that I did. All right, I'm kind of wondering about that cancellation that I did. See, x possible x minus 3 is the answer as well, because normally you're doing maths, you're not really supposed to cancel what you're trying to find. So let me do this another way. Let me take this and expand it across here and see what happens. Let me just try that. Let me just try that. Let me just take this. Let me leave this as this and put it as 3 cubes. I'm just gonna try something else, right? So let me just shift this over here. So I don't lose the solution. And let's try something. Just want to see if I cancel out another answer. It's always not good practice to cancel out something that you're trying to find. All right, so let me just do it another way and see if I've eliminated an answer. So I'm going to leave this as x squared minus 9 over x plus 3. So this will be my number. And then it now, so like I'm writing this back here. And I'm putting it equal to 27. This 3 cubed is 27. Starting back there. I'm going to multiply this over here now. And I will get x squared minus 9 equals 27x. And then plus 3 times 27 is what? 81. 3 times 27, 81. And I transpose, I will get x squared minus 27x. Transpose this now, and I get 81 and 9 is 90. 90. And it's a minus 90 equals 0. All right. And then now on factors of 90, where the difference is 27. Factors of 90, where the difference is 27. That's 30 and 3. See, it's true, I eliminated an answer that I should not have enough. So it should be x and x, 3 and 30 for 0. Then now signs are the different, you will get one the minus here plus here. So we'll get x equal -3 from this factor. So hope you all learned something from this. X equal -3 or x equals 30. So you see, by dividing out these, I eliminated a possible answer. Right? And I was kind of hesitant to do that because I know you must never cancel something that you're trying to find from an equation. So you're getting x equals this and this. So this is actually the answer, because the -3 actually can work. Oh, -3 can work. -3 can work. Because look at -3 can work. But take the -3 and I put it here. I will calculate in the log of the base 3 of 0. log of 0 does not exist. So negative 3 is not a valid answer. Similarly here, I'll put the negative 3 here. Same thing that will happen. I will be calculating log of 0 again. So negative 3 actually cannot work. You can see it here, so you can't find the log of 0. Log to base 3 of 0. See, error message, can't work. All right, so this is not a valid answer. So if you did it this way, the point is, if you did it this way, right, and I got these two answers, you would have to say that this answer is not valid because it cannot work in the original equation. All right, so you could have done the question this way, but you have to declare that this answer is not valid. And so this will be the answer anyway, so it's okay. Understand that, guys? So this is our OR method. But good at that? Hello?
Yes, sir.
All right, so that's why I don't like online class and I hate it now, because I feel like I'm talking to myself. I don't like online classes anymore. All right, this one says, to show that this thing is standard equals that. So basically then this is us simplifying this expression, right? And that's a square root and thing. So I have this, we're gonna look for some perfect squares in it. So the left-hand side, and watch this, I see this root 5 here under here, so I'm gonna work with it. Since I see this root 5 under here, root 5x, sorry, I'm gonna factorize the root 5x out of each of these. So left-hand side is gonna become the square root of, if I factorize 5 out of this, what am I getting? 320 divided by 5, 64. So this will become, 64 x squared times 5x. So factorize 5x out of this. Plus, do the same thing with this one. Factorize 5x out of that. So divide that now by 5. You're going to get 25. So we're going to get 25 x squared times 5x. All right? Now what happens now is that this part of it, the square root, it becomes 8x. This part of it becomes 8x. I'm going to get 8x, and then the root is still over the 5x. Root 5x. Plus, this one now, this becomes 5x. And you have root 5x again. So 8x and 5x equals 13x. And each of them multiplied by root 5x. And therefore shown. So showing it. Nice and easy like that. Very good. But okay, 4 marks I give for something
Yes,
simple
sir.
like this. Now pure maths said that. Pure maths easy, you know, that joke. Look at that easy. Look at that. Huh? So this could have come on an add maths paper as well. All right, so we could check our add maths paper now. So since you have both add maths and pure maths students in the class, let us check our add maths paper now. All right, let's check our add maths paper. All right, so we could do 2023 as well. All right. right, I'm looking for the surds. If there's any. Surds, logs, and indices. They don't get them on every paper, now, guys. All right, so we did this in the class. I said these guys, quadratic equation. So we actually did this in the class. It says we have to solve this. So indices. So we have to solve this and give the answer to 3 decimal places. All right, so that's how this guy's quadratic equation. So if we use the laws of indices, we're gonna split this up first. This one. What does that become? This initially becomes 3 to the 2x times 3 to the 1. We'll do it this way. And the power is 2x plus 1. Minus, this stays as it is, 5 into 5 to the 3x minus 2 equals 0. Then this now can come to the front as 3. And it's 3 to the 2x. This 2x can split it out into 3 to the x squared. Because x times 2 still 2 times x. And this 3 to the 1 is this 3 right here. Minus 5 into 3 to the x minus 2 equals 0. So when our quadratic with the variable is 3 to the x, it's just like 3y squared minus 5y minus 2 equals 0. Same thing, but I'm not going to work with the y. I'm just going to keep the 3 to the x. So I want to factorize this now. Factors of this is 3 times 3 to the x, just like it have 3y, and 3 to the x. The factor of this 2 is 2 and 1, but I will put the 3 with the 2 over here and 1 there. Signs are different. If we greater product, the minus sign, the greater product is the far one. It minus, this one plus. Those are the two factors. So if this factor equals 0, then this 3 to the x will be equal to minus 1/3. Or this 3 to the x will be equal to 2. This one is not valid because a positive number raised to a power cannot be negative. So this one has no answer. And if another way to look at it is that if to get this x out of the power, you have to take logs of both sides. It's another way to look at it. You would have to take log of this side and log of this side. But you can't find the log of a negative number. So anyway you want to look at it, that is not valid. So we're solving this one now. So to get the x out of the power, we take logs. We're going to take logs on both sides. So you're going to log this side. You get the log of 3 to the x equals the log of 2. This x comes to the front with that power log law. And so you get x log of 3 equals the log of 2. And so x equals the log of 2 over the log of 3. And basically whatever that works out to is the answer. Let's give an answer to how many decimal places? 3 decimal places. So we can work this out with the calculator. Log of 2 over the log of 3. Log of 2 over the log of 3. 0.631. 0.631. 3 decimal places. 0.631. That is it. All right. For these factor theorem, see if there's any logs on the paper. Straight. By the way, before we move on, I better go to that. Put it that?
Sir.
Yes,
sir. Yes, sir. Yes, sir.
All right, cool. Let me see if there's any logs on the paper now. It's quadratics. One product of roots. Series. Pillars of circle. Vectors. I think there's no logs on it. I don't remember where logs would come on the paper. So I'm looking through. It's not here. Apart, there's no logs on it. That is it. All right. So let's go back to our pure maths paper now. Let's look at 2023 pure maths. 2022, I should say. Pure maths 2022. All right, looking for logs on this. Surds and Indices, whichever one comes up first. It's a logs question here. This question again, similar to the one that we just did. Very, very similar. This question could be an odd maths paper, the level of it. So just like this is sum now. When there's a log, take the log of a sum, it becomes a log of the product of those values. So this equation becomes the log to base 5 of x plus 2 times x plus 6 is all equal to 1. All right. So this is the number, this is the base, this is the power. So this number equal 5 raised to the power 1. Or we can say log of a number to its own base is equal to 5. Is equal to 1, sorry. Log of a number to its own base is equal to 1. Means that this number and this is equal. So the number is equal to 5. Expand this out, we get x squared minus 8x plus 12. Or did I get the not minus, plus? Or did I get the plus 8x? Far product and the near product give me the middle term. That's 8x. It's supposed to be at 12. 2 with 6 is 12. And that's all equal to 5. Transpose x squared plus 8x minus 7 equals 0. Plus 7. Plus 7. Go over the 5 and subtract, I get plus 7. Factorize this. I get x and 1 and 7 plus equals 0. So I'm getting x equals 1, negative 1, sorry. X equals negative 7. I'm going to test the answer that I get. Because logs are a very peculiar function. You know? When you get answers, you have to test them. You cannot just accept what you get. You have to test to see if these values that I get would work. Now watch this now. If I take the negative 1, and I plug it to for the x, and I plug it to for the x, this will work out to be the log of 1, which is okay. This will work out to be the log of 4, no, log of 5, which is also okay. So it's okay for x equals negative 1. So this one, sir, is an answer. Let's test this now. This is not where I'm working. Because I put negative 5 right here, negative 7 right here. I'm working on log to base 5 of negative 5. But you can't find a log of a negative number. So it means that the negative 7 is not valid. Same to what I've happened here. I put it here instead. Now we're working on a log of negative 1. Which again is not valid. All right, so this one is not a valid answer. That is it. That is that. All right, let me see what this is there. That question is finished. I don't think you're gonna see anything else. That's pure maths. All right. See how this guy's quadratic equation here. Let's do this one. Let's do this one. All right. So what that means that these can be brought to base 2. And I'm gonna write this 4 as 2 squared. All right, that's the first thing. All right, so I'm gonna have it written as 6 minus. I can write this as 7 over 2 to the 2x minus 3 over, if the 4 is 2 squared, let's write what this becomes over here. So the 4 to the 2x is the same as 2 squared to the 2x, which is the same as 2 to the 2x all squared. So this is what I'm going to use over here. I want to generate the 2 to the 2x. That's what this becomes right here. Equals 0. What I'm going to do, I'm going to multiply through by this. As the highest common factor in the denominator, lowest common multiplier in the denominator. All right, this one. So multiply through by that. Multiply through by that, I multiply this denominator by this first. I get 6 times that. So I'm going to get 6 bracket 2 to the 2x squared. Multiply this by it, I'm going to get minus 7 times it. Multiply this by it, I'm going to just get negative 3 equals 0. So it's become a quadratic in 2 to the 2x. Same as 6y squared minus 7y minus 3 equals 0. All right, so the y is this, 2 to the 2x. I need to factorize this now. I'm going to break this up into 3 times 2. 3 of this, 2 to the 2x. And 2 of it here. I want to put 3 with 3 and get 9. All right, get 9 over here. 3 with 3. I'm putting factors of this here and there. And then put the 1 right here. And then 9 minus 2. This is going to be 2. Give me the 7. All right, so the 9 has to be negative because the larger product to get a negative middle there and plus there. So those are the values, the factors, sorry. So this one, to make this a subject, I'm going to get 2 to the 2x equal negative a third. Or this one, I'm going to get 2 to the 2x equals 3 over 2. Now this one is not valid because a positive number raised to a power cannot be negative. So this one is not valid. All right, so now we're solving this. Remember, if the thing that you want to find is in the power, you must take logs. So I'm going to take log of both sides. All right, so I'm going to end up getting, and at pure math, you take ln. Let's write the ln this time. I'm going to take ln at both sides. So I'm going to write ln 2 to the 2x, ln 2 to the 2x equals ln 3 over 2. That's 1.5 and 1.5. Same as 1.5. So I'm going to write 1.5 for this one. All right. Then now, 2x. I can move the whole 2x to the front, you know. If I want, I can just move the x alone to the front and get x ln 2 squared equals ln 1.5. Then this 2 squared is 4, so I get x ln 4 equals ln 1.5. And divide by this, we get x equals ln 1.5 over ln 4. Whatever that work out is the answer. That's it. Whatever that works out is the answer right there. But go to that.
Yes, sir. Yes, sir.
All right. That's pure maths, right? Pure maths. All right, I don't think there's any logs and indices on this. That's 2022. All right. Let's look at ADMAS 2022 now. To come up on something, I must give you a minute to do it. And then I come back to it. ADMAS 2022. Let's see. A very easy question. Show that this is the same as that. So this is the same as that, right? So left hand side, where the square root of 25 is 5. All right, so we can leave that. You can put the 5 over. This 45 is 9 times 5. I'm write as the square root of 9 times 5. Square root of this 9 is 3. This becomes 5 over 3 root 5. Then now to get rid of this, I need to multiply numerator and denominator by root 5. I don't want root 5 on here. So I'm going to multiply numerator by root 5, multiply the denominator by root 5. And what happens is that this root 5 times this root 5 is 5. So it becomes 5 root 5 over 3 root 5. Then root 5, no, I make a mistake, This root 5 times this root 5 is a 5. So it's supposed to be a 5 on here. 5. 5. This is this 3 right here. Root 5 times root 5 is 5. So these cancel now. This and this cancel. So you're left with root 5 over 5. Root 5 over 3. Root 5 over 3. Easy stuff. This is quadratics. And the grade. Think we're good with that. Think we're good. Yeah, I think we're good. I think we're good with that. All right, so we're back at our key paper now. This is got 2021. All right. I'm gonna put this on the screen. Give you a minute to do it. Notice that the base different. We bring everything to the same base using the change of base law. Remember, how the change of base law works is that the log of a value to a base is equal to the log of the value to the new base over the log of the base to the same new base. So that is it. That's what the change of base is. I bring everything here, so all this to the same base. What I would is bring them to base 2. I have base 2 already. Bring this to the base 2 and bring that to base 2. And let me see. So let me give you 5 minutes to do it. Let me see if there's another part to this question. I hope 6 marks for it. And for the clock. I don't have it. Next second, bring up the clock, guys. Oh, see there. All right. Come, try this question for me. This question. Solve it. I'm saying this is a change of base law that is applicable to this question because the laws that we learn are when the base is the same. To make sure that all expressions have the same base. All right, 4 minutes to go. Very good. Okay, guys.
Yes, sir. Yes, sir.
Make sure that all expressions have the same base. But finish?
Yes, sir.
Yes, sir.
All right, let me stop this then. And let me do it now. I'm going to bring everything to the lowest base, which is 2. All right? So I'm going to keep this one already at base 2. It's going to come as log to base 2 of x plus this one now is going to become log of x to base 2 over log of 4 to x to base 2. Log of x over the log of 4 with all of them to base 2, both of them to base 2. And this one now becomes log of x over log of 16, log of x over log of 16. Base that we want is 2, so 2 here, 2 is there. That equals 7. All right, now this 2, this 4, is same as 2 squared. So I know that this work out to 2 in, it's going to work out to 2 in. Right? But let's say I don't know. This is same as 2 to the 4th power. Right? This 60 is same as 2 to the 4th power. So it's going to work out to be 4. Right? And in fact, a calculator can work this out for you and give you those values as well, if so be the case. So just to show you. That numeric, so we can actually work them out. So log to base 4, log of 4 to base 2. It's going to be 2. See it there? So this is 2. This is 2. All right, so the equation becomes log to base 2 of x plus, this becomes a 2. So divide by 2 is same as taking a half, right? So I'm going to write half of log to base 2 of x plus, and then this is now going to become a 4. So if I look at it, log base 2 of 16, so that's a 4. So this is a 4. So like this divided by 4 is a quarter of log to base 2 of x. That's equals 7. So I could add in 1/2 and quarter to consolidate all of this. 1/2 and quarter. Let's see what it is. 1 plus half plus quarter. So the 1 and 3/4, yeah? Half 2/4 there. So the improper fraction will get in this. 7 over 4. So all this becomes 7 over 4x. 7 over 4 log of x. So it becomes 7 over 4 log to base 2 of x equals 7. All right, so to make this a subject now, I'm going to multiply up the 4 and divide another 7. 7 is going to cancel. So we're going to end up with log to base 2 of x equals 4. If you want to find x, that x is equal to this base raised to that power 4. So the x is now equal to 2 raised to the power 4. And that is 16. Is it? Very good. What I got the 16? Anybody got the 16?
Yes, sir.
Yes, sir.
Ah, good. All right. Pure maths. Let's see if there's anything else. I don't think so. All right, so go back to add maths now. 2021. Advanced 2021. Let's see what's on this one. Terminal theorem, quadratics. All right, so a question here. This is a question right here. That's it. It's find the value of A. Advanced and pyramids. Come. You have 5 minutes again. Don't even need so much. Tell me when you finish. Now put up 5 minutes. When you finish, I'll break. Base is the same. After base 2. Find the value of A. This is log of 10 and log 10, log of 10. It's a value, log of 10. Actually, gonna be 1. And don't put in the base on it, so it means log to base 10. Everybody finish?
No, sir.
Everybody finish?
Yes, sir.
Finish? All right. All right, let me do it now then. That's what you all got. All right. Well, first, this minus means I'm going to divide the two values, right? But we're already at base 2. So left side becomes log to base 2 of this divided by that. 6 plus root 12 over 3 plus root a. And that's all equal to this is a 1. Log of 10 is 1. It therefore means, since the log of a number to a base is 1, it means that the number is equal to the base. So we're going to have 6 plus root 12 over 3 plus root a is equal to 2. This log on this base is the same as the equal 1. Cross multiply. Take this and multiply across here. So we're going to get 6 plus root 12 equals 3 2 is 6 plus 2 times this. So this 6 cancels this 6. So we get root 12 equals 2 root a. Multiply to this now. Can square both sides of this and get 12 equals 4a. We divide by this 4. We say a equals 3. That's the answer. Y'all got that? What got that? No? So I didn't get it.
No.
Sir, I get you.
All right, so question like this have rework, right? Very easy. All right, giving that out. Advanced. All right, let's look at 2020 pure maths. No, there are no exam paper in 2020 for pure maths. We have paper 1 alone. All right. 2019 pure maths. A question here. That one, guys. We have 5 minutes again. What did I do? Oh, what's the wrong thing? Here. Where that one from, guys? Advanced and pure maths. This one easy. What if finish? About to finish?
No, sir.
All right, I'm gonna stop it now.
Okay, sir.
All right. This one give you it's another this guy's equation. I'm gonna write this as 3 minus 4 over 9 to the x minus 4 over 9 to the x squared. But that's how I'm gonna get from this to this equals 0. Anybody can say I'm gonna get from that to that?
Yes, sir.
I'll put it the right still. 81 to the x, the same as 9 squared to the x. Nine squared to the x. This is 2x. But it can be switched around and written as 9 to the x squared. The product is 2x, the product is still 2x. That is it. So that's how I end up with that there. Then I can multiply through now by this denominator. If I multiply it through by 9 to the x all squared, I'm going to get 3 times 9 to the x all squared. And then 4 times 9 to the x. And then minus 4 equals 0. That is it. This is like 3y squared minus 4y minus 4 equals 0. All right, let's see what we can do this now. Factorize this up. It's 3 times 9 to the x. Let's write this better. And the 9 to the x in the second bracket. I want a 4 to be my middle difference. I'm going to put 2 over here, so the factors of this 2 and 2. 2 and 2. So they are different. You have to put a minus sign. You have to put it this one, make it minus. That is plus. So this fraction, this bracket, sorry, you give me 9 to the x equal minus 2/3. Or this one is giving me 9 to the x equals 2. This one is not valid because a positive number raised to a power cannot be negative. So this one is not valid. Then this one now, get x out of the power by taking logs. Get x out of the power by taking logs. So you're gonna come x log of 9 equal log of 2. So x equals the log of 2 over log of 9. That's it. Any questions on that? No? But all right?
Yes, sir.
All right. Let me see if there's any logs on there. That's all I can do. Streaks. All right, now no logs to do. All right. Well, let's look at AdMax 2019 then, no? Alternating between the AdMax and the PureMax. So look at AdMax 2019. I want to prepare this one as a C-sec. Let me show a C-sec. So easy collapse question there. Yeah, I'm gonna give you 5 minutes, but I know you're gonna finish it before 5 minutes. Hit there. 5 minutes. Start working. Everybody finish? Anybody finish?
Not as yet, sir.
Anybody finish now?
Yes, sir.
All right, let's see. All right, so looking at this, there's some similarities in these two wires. But I know you can take this tree and bring it up here as a power. I can take this X and bring it to the front. I'm gonna do that because it's convenient. So this one it will come up, it's gonna become X log of 2 cubed. And this one is gonna become X log of 8 equals 2. But this 2 cubed is also 8. So we have X log of 8 plus X log of 8 equals 2. But this is two of these things. Two of them adding together. So it's 2 times that. So it becomes 2 times X log of 8 equals 2. So to leave X as a subject, we divide by 2 times the log of 8. So X equals 2 over 2 log of 8. 2's cancel. So we're going to get 1 over log of 8. All right. But got that?
Yes, sir.
All right, good. All right. But I'm going to go back for a pure maths paper now, 2018. Let's find 2018. Pure maths 2018. All right, so easy one here. Change our base law again. Another one. Remember, 2 bases different. 4, 4, and 2. We have 5 minutes again. In 4 minutes. Guys, finish?
Yes, sir. Yes, sir.
Yes, sir.
Alright. All right, let's see. So we're gonna bring everything to base 2, right? Base 2. So this one becomes the log of 2x plus 2 over the log of 4 plus the log of this over the log of the base to the new base of 2. 2 minus this remains log to base 2 of x plus 1 equals 1. Now, this under here is just equal to 2, because this 4 is same as 2 squared. This 2 can come to the front, it will be 2 log of 2 of 2, log to base 2 of 2. So this part of it will be equal to 1. So anyway, take it, that equals, this equals 2 under here. So this then becomes like half of this. Right? Because we're putting a 2 under here, so like half of this expression. So it's gonna become half of log to base 2. You can factorize this and put 2 times x plus 1 and about. Yeah, let's do that. 2 times x plus 1 minus the log to base 2 of x plus 1. And that is equal to 1. All right. Now, I can multiply 2 by this 2 to get rid of the fractions. But then I'm going to have to put that 2 up here as well. I'm going to multiply 2 by the 2. Another option that I have is to break this out and put half log to base 2 of 2 plus half log to base 2 of x plus 1. And then minus log to base 2 of x plus 1 equals 1. And this will just become a half. Can do that as well. All right, let me finish it this way and then come back. Let me finish it this way and then come back to this line and do it another way. Let me do it that way. Let me finish it this way. So I'm going to break this out. So that me have half of this in them. So we break this out, you have half of the log of the 2 plus half of the log of this part of it. Using the first law of log, but I'm breaking this into the sum of 2 logs. So I'm gonna get half log of 2 base 2 plus half log of the base 2 of x plus 1 minus log the base 2 of x plus 1 equals 1. But this right here so is equal to 1. Log of 2 to base 2 is equal to 1. So the whole of this just work out to be a half. So I get a half. And then this becomes a half of something minus 1 of that something. So I get negative a half. I'm gonna get the minus a half log to base 2 of x plus 1 equals 1. So then when I take this, I can transpose it over here, make it positive, and then bring this over here to subtract. Or I can just multiply 2 by 2 right now. Multiply 2 by 2 right now to get rid of these fractions. So I'm gonna get, when I multiply 2 by 2, this becomes 1, this becomes 1, and this becomes log to base 2 of x plus 1, and this becomes 2, multiplied by 2. So anyway, take it and transpose this and get it positive. So I get log to base 2 of x plus 1 equals, and then this 1 minus this 2 gives me negative 1. So it means that this number is equal to this base raised to this power. right? This number is equal to this base raised to this 4. So I can say that x plus 1 is equal to 2 raised to the minus 1. 2 to the minus 1. 2 to the minus 1 is a half. So x plus 1 is equal to a half. And so x is equal to negative a half. Let's subtract this one. X equal to negative a half. That's what I'm getting right there. X equal to negative a half. I want to try the other way. Where was it? Where there? I didn't want to split this out. I want to try it another way. From right here. Right here, I split this out into these two terms. I want to try another way by multiply through by this 2. So I'm going to do it over here. So from this line, I'm going to multiply by 2 instead. See if we get the same answer. Multiply by this, multiply by 2. This becomes log to base 2 of 2 into x plus 1 minus 2 times this. Let's zoom it up a bit. Right, so I multiply this. I know I'm gonna copy this over this side first. This. Let's copy it. Paste over here, so. I'll go from that. So I'm doing it another way. I'm using this right here. I'm gonna times 2. So I'm zoom in now. Now times 2, this half gone. Right? So I'm gonna get log to base 2 of 2 into x plus 1 minus this times 2 gonna give me 2 times log to base 2 of x plus 1 equals this times 2 is 2. This 2 need to come up here as a power now. So I'm gonna get log to base 2 times x plus 1 minus log to base 2 of x plus 1 squared. When this 2 come up here becomes squared, all of that is equal to 2. This minus means that I'm dividing this by that. I'm taking the log. So I'm gonna get log to base 2 of 2 log to base 2 of this divided by this, which becomes 2 into x plus 1 over x plus 1 squared. And that's all equal to 2. And x can't equal 1, you know. No, x can't equal minus 1, because if x equals minus 1, then this going to become the log of 0. So because x can't, put it this way, x plus 1 cannot be 0, but you can't find the log of 0. So because x plus 1 cannot be 0, you can divide by it. So I can divide by it. All right? So I can divide by x plus 1 here. So I can divide it out here. So I can divide, cancel this with 1 of this. In any case, this is going to become log to base 2 of 2 over x plus 1. That is equal to 2. And then now what happens is that this becomes a number equal this base raised to that power. So I'm going to get 2 over x plus 1 equals 2. That is this 2 raised to that power 2. And this is 4. All right. So I can take this. All right. And this equals 4. So this is the same as 4/1. So I can take the reciprocal on this side and get x plus 1 over 2 equals this the reciprocal of that and get 1 over 4. Multiply this 2 across here, I get x plus 1 equals, I multiply this 2 over here, 2 times a quarter is a half. And then take this one and subtract it, I get x equals minus a half. Same answer. X equals minus a half. Doing it 2 different ways. That's it. Want to go to that? So then I ask a question that are gymnastics on it. But that is it. Go to that, guys. Hello.
Yes, sir.
All right. So I think I'm gonna give you one more. Admaths 2018. Let me see if there's anything else on this paper for you. Nope. I'm gonna give you Admaths 2018 now. And then after that, we'll just call it a day. I hope you work these questions over again. I'm gonna send the video so you can, look back at it if necessary. Where's the level of exam question that you're getting? All right, see that it's not difficult, easy stuff. But you have to know the laws of logs to do all those jugglings. You have to know the laws. All right. Admaths 28. It's a logs question, but we don't do this part of it yet. It's a really linear reduction. I don't do that yet. Do this part in linear reduction. So I think that's it. Not on this paper. All right, I think that's it. Yeah, that's it. There's none on this paper. The logs on this paper is more a linear reduction question. All right. Understand, no good?
Yes, sir.
All right. So when you redo those questions, watch about the video. I'm gonna send you the video. So I'm gonna bring up the questions and redo them, and then use the video to assist you where necessary. But let's try the questions over again. So you see the level of questions, see the standard of questions. And this guy is an easy topic. We didn't get much surds to practice here. All right, but we're gonna practice some surds otherwise. All right, but that is it for today. All right, guys. So remember, we're not having a class this week. I sent you a schedule of we're not gonna resume classes because I have to travel.
Yes, sir.
So, all
Yes,
right.
sir.
So keep practicing. And what I'll do, I'll stay in touch online if necessary. All right. All right then. Cool.
All right,
Bye
Yes,
bye.
sir.
All right. Bye bye.